Okay, hello everyone. Welcome back to Erosion of Earth. In this video, I am going to be responding to a comment that I got on Instagram actually, where the user said it seemed as if there was a current that washed through these ranges here. All of these ranges seem as if they've got channels in them. And it seems as if to this user that water washed through Nevada in this area here and entered the Gulf of California, right by Baja California and right by Mexico. So we're going to be discussing that, and I've got some pins that shows this. Now let's first talk about this range here, and I don't want to get too much into the Bonneville area because that should be a topic of its own. But as far as this range here, this is mostly due to tectonic forces. However, obviously from these rivers, we can see that water did wash through here. But the most evidence of water washing through this area here and leading into Baja or the Gulf of California is actually in this area here, where it's somewhat of a valley and somewhat of an expansion bar. But this larger area here is where we really get a lot more detailed evidence of a water current. Not to say that there's not evidence here. It's mostly lakeshore or accretion ridges and some other stuff, but the best evidence is in this area here. Now, I'm going to dive into this area and show you guys these pins. But before I do that, I also want you guys to understand that the Washington Basin here was also filled up with water. And these channels here, the channeled scablands, flowed down. And this basin was actually very full. And we can know that by studying accretion ridges. And let's find a good spot right here. So when we go to this spot here, we find terraces and mounds, and all this is from water erosion. And let's see if I can find, we can see the lakeshore lines. We can see the accretion ridges. This whole area is full of features that show that water was filled up very high, thousands of feet high was the water that covered the Washington Basin. And it went through this channel here and went down to the south. We've got current ruts that indicate this. You can go parallel with the current ruts, and that will show you where the current went. Over here, some good current ruts as well. But the large valleys, parallel valleys, and fairly straight valleys go due south. I do this on one take, so that's embarrassing. Due south. And we've got some nice scours. But I've already talked about this, so let me get back to the topic. So we keep going down. We get all this indication of water washing down here. And it continues, and it does go through down to Baja. So let's take a look at some of these pins and see what we find. Here we've got some nice lakeshore lines that go very high up. And this is all salt here. This is salt scablands. Here we've got some more lakeshore lines. Very high up on these mountains, incredibly high up, and they're very distinct, and they're all over the place. So this place was filled up very high with water, saline water, that is. This is Pyramid Lake, beautiful scour, and here we see a sediment lobe feature that actually shows a current washing this direction. Very bizarre, but there's actually a lot of features that kind of go across as if water washed down and over this ridge. Let me show you another location of this. This is in Nevada here. So these are sediment lobes. This is something that you will find on the bottom of a river. And then you find, decent sized ripples. These are probably 200 or 300 feet in wavelength. And sediment lobes with massive ripples. And it goes right over this shallow mountain here. It goes this way. This is kind of the end of the lobe here. But you can see it's full of ripples. This area here is full of ripples. Okay. But that's not really what we're talking about. The main current we want to talk about is the current that washed due south. So let's keep going with our study of the pins. Here we've got some sediment lobes. These are actually also kind of pushed to the east. Let's see what this one is. Here we've got some nice accretion ridges. Also pretty high up. They go all the way up high. Even all the way up here. And this is a desert. And yet we see distinct ridges. Okay, this is Mono Lake. Sierra Nevadas are right here. Now this is a really cool spot. You guys are going to like this. Saline body of water. Here we also find sediment lobes pushing to the east. And here we find some nice river banks or lakeshore lines, right? But because of the current, it's basically like a river bank. But technically I'd call that an accretion ridge or a lakeshore line. Now, here, this is a cool spot. So you look at the shape of Mono Lake. It's got that distinct scarp edge with another scarp edge leading into it. But here we find that these sediment lobes are pushed forward, right? We can check the current direction. Pushed forward. We've got really nice ripples here. And these ripples are organized into paths almost. Like here's a straight line path of ripples. And let's get a quick check of the 300 feet. Yep, that's pretty good. And then they keep going and you find them kind of around the lakeshore lines, the accretion ridges. We go up here, we find, yep, it's still terraced. So all of these indicate a water level. But this is not just sand, this is now being carved into rock. So it's getting a little more impressive. But this feature right here is very cool. Can you guys see this feature here? Oops, I hate when it does that. So this is a rounded shape. And then this is a scour. So you would call this a cataract feature, and you'd call this a plunge pool. And then you've got sediment lobes indicate or verifying that classification. So imagine water comes through here. I mean, water way above this, these rocks here, and it kind of focuses in this area, and it plunges right here, digs out this trough, digs out this plunge pool so that even water can collect in the arid desert. And that all of that water flow then pushes this sediment forward, creating sediment lobes, which pushed forward this way. And then you've also got, probably 200, 300 foot ripples here to verify that. And then over here, you've got some other nice ripples here. Let's get a wavelength, 200 or so. All right, let's skip over to these guys here. Let's see what this one's about. This is also, these are also ripples here. And this is really the best one here. So all of these valleys, right? So you can clearly see that this was a river valley. And you see how this river valley, it has ripples only in the valley. You go past the valley, there's no ripples here. But right in the valley, there's ripples. So this is very clear indication that we can interpret all of the features around this, all the lake shorelines, all of the sediment lobes, all of the accretion ridges. We're going to look at mounds and massive ripples later on. This feature being so clearly fluvial, by having massive ripples in these channels, it validates all of those. So these are much bigger. Let's check a wavelength. This would be a clean wavelength here. It's 300, so I guess it's not that much bigger, but we're going to find some really big ones. So you guys better stick around. And then also this area here, it gets a little less clean, but you can still see it's the same idea.
I didn't get that.
Oh,
Could you try
Siri,
again?
please stop. And then, so
Okay.
yeah, we've got saline deposits here. And all of these are ripples. You can, I mean, these are really beautiful ripples here. And let's take a wavelength on this guy. Yeah, so they're getting a little larger. And then also, if you go, this spot here also has them too. Something like this, a valley like this. Now you can find these features all over the world. Somalia, oh boy, Somalia has some nice ones. Another spot, there's some good spots in the deserts in central Mexico. And even South America's got some really nice ones, thousands of feet in wavelength. But let's go, okay, yeah, so let's check out this guy here. So now we find, what is this feature here? These are current ruts, just like what we found in Oregon and Washington that led down. So these are all created by water. Wind obviously can't carve these channels into bedrock. So this is another great feature that proves very strong water erosion. And so basically you can zoom in a lot of places and find ripples, some more organized than others. So let's check out this spot here. Find a nice little patch of ripples here. These are some big sand dunes. But from the aerial view, we can see that how they were deposited. Let's go over here. Now this is a cool spot because we've got ripples perpendicular to the current. And then when we go over here, we've got features parallel with the current. So these are drumlins because they're parallel with the current. And they're also kind of like sediment lobes because you've also got that point where they're pushed forward and you can see where they grew from, right? These points here. So drumlins / sediment lobes. Here are some other ones that have that point, right? And then when you get a feature that's more perpendicular, then that would be ripples. And these are very cleanly organized here. Okay. So yeah, these ripples show that water flowed right down through here, down through here. And let's check out this spot. Okay, here we've got a scour. Right, this lake here was scoured out by the water. And so the water, sheet water flow will, or large water flow in general, it will want to focus and it will want to dig a trough. kind of like a plunge pool, but it's not exactly focused around a cataract, so it's more of just a scour. Now, if we go over here, these are alluvial fans, fluvial even, strictly fluvial. Now, the reason why you know that these can't be from a landslide or anything other than being deposited completely underwater is because of the shallow angle. And we're going to find some way more shallow than this. But in order for it to not be fluvial, it has to be at a much steeper degree at the point of repose, the angle of repose, which is, it varies, but it can't really form any shallower than 30 degrees. And I'll talk about that later when I talk about moraines. Okay, let's keep moving. So here we've got some more scours, and we find it's just kind of just mud cracks here. But over here, past these, ooh, look at these scours. Ooh, those are nice. Paths of scours. Oh, I haven't even noticed this actually. So this is the water path scoured out in such a way that it's almost like it's making mounds. And let's see if we can find some mounds in this area. There's got to be some mounds. There's mounds everywhere. Here we find some nice accretion ridges, lake shoreline, so we can keep track of where the water current once was. So this was all completely underwater. So here we find some mounds, right? So the water kind of washed around and sculpted out these mounds here. These aren't the cleanest. There's definitely better ones. And then I think, let's see if we checked out this spot. Yeah, that's the scour. Let's check out this spot. This is kind of by Palmdale. Come back to me. All right, check this out. Here we've got some nice sediment lobes. All right, pushed forward this way. So we got to zoom out and we can see it came through this way. Now this looks like a massive expansion bar, but I think this mostly has to do with tectonic forces that shape that. But water flow could have had some part. But if you can see this line here, this is part of a fault line. So when you're studying erosion, you have to understand how much the tectonic forces have to play their role as well, the underlying geology and stuff like that. Okay, now check out this spot. Here we've got a nice marine terrace, and it's super flat. So how do you get something so flat? Well, something that's good at flattening a surface is sheet water flow. Just like a river terrace will be completely flat. So this is indicative of a current that smoothed it out. And then later, these ravines went eroded backwards into there. So that's how ravines erode. They don't start in this spot and grow wider. They move backwards. Okay. Let's check out these. Okay, so here we can see how a current washed through here, kind of streamlined around here, and it went through this way. And then we can see some interesting features. Now here we start to find more mound-like shapes. Right, now we get some mounds. And somewhat of ripple shapes as well. See how much bigger these ripples are starting to get. 190. So not massive, but still, if that was, found near the somewhere in Washington, we'd definitely call that catastrophic. That's for sure. But now we're just in a simple desert. So this spot here is a great example of how all of this sediment was deposited underwater, because of a few reasons. Number one, of its shallow angle, its shallow slope. Number two, how minimal the erosion on top of this is, and how it doesn't match the erosion of this mountains. These mountains, being made out of solid rock, are more eroded than sand, which is unlithified. It's not even a rock. So that's another example of how all of this sand was deposited and settled completely underwater. It's an important point when you take a step back and you look at all of this sand, all of this sediment, and how it's at an incredibly shallow angle. All of this settled completely underwater. That's a fact based upon angles. Okay, so now we've got an idea of how water flowed from the Washington Basin, came out through here, also washed through the Oregon Scablands, washed down this way, and came through here. But another major fact of the erosion is water came actually through here. This is a very clear erosional path. Let me show you without all the pins in the way. Came right through here. And the Salton Sea is a scour. This valley is undercut because of the force of the water current. Now let's take a closer look. Let me just start off by showing you the best spot. So what is this feature here? This is the line of sediment, and it's got massive ripples on it. Massive ripples. So let's get a wavelength on this guy here. From crest to crest, almost 3,500 feet. Crest to crest on this guy, 5,700. That's nearly a mile, right? A mile is 5,000 or 280, isn't it? Maybe that's over a mile. Let's check. This might be over a mile. Yeah, it's over a mile in wavelength. And it's got a distinct line path, and that's in line with the Salton Sea, which is in line with the river valley here. And what was I talking about here? Oh, here we find some nice sediment lobes. And then so the river, or the current, went through this area, through here, through LA, and then through this little scarp edge here. That's what's responsible for this marine canyon. And if you look at this marine canyon, right, this is from an underwater debris flow. So all of this current was able to move rocks that then created this underwater debris canyon, or marine canyon. And it kind of looks like it curves through here. And it looks like this is also a part of that marine canyon. But we can't really trace it very far just because of a lack of data. And it's all extremely pixelated. And then this is another marine canyon that begins incredibly abruptly. I mean, you look at the land here, it looks completely flat. No, not a problem. And then all of a sudden you've got this massive canyon that doesn't match the land above. That's because this is the bottom of the channel, and the channel was carrying all of this rock, and it started eroding right here once it dropped off. And it came around, we can see it came through here, and then we kind of lose it, but I'm sure it continued more. Okay, now so I want you guys to understand that the path of the water, was like this. Okay, now let's check out this pin here. So here we can see rivers cutting through a tiny little, almost like a little range. And this is actually a really nice river terrace, which made it nice for these builders because it already leveled the land. So here you've got the river valley here, which is now just a street and buildings. A river terrace here and a river terrace here. So the water was once running along this edge, this bank, then it was running along this bank, and before that it was flowing over the top of this in order to make that a flat terrace. So out of all the land we can see in this area, all of it shows signs of it being completely underwater. And then on the other side we also find, the valley terrace, second terrace, third terrace. But wait, there's more. Let's check out these pins over here. Here we've got some lake shorelines. Lake shorelines, many of them, right? You can count them up if you want to, but there's a lot. So that's an indication of water level. So just imagine all of this has evidence of being underwater. And now think about this. This is on topsoil. This is on topsoil. Most places it's only dated to be anywhere from 10,000 to 100,000 years old. So it really doesn't make sense for this to have lake shorelines on it. The elevation is 410 meters, which means it's almost 1,300 feet in elevation. So as far as uplift goes, it still doesn't make sense for this to be underwater. It kind of changes our entire thinking of basically everything. There's another spot with a bunch of terraces, more like accretion ridges / terraces. And this is also exactly what we find in the Salinas Valley, which leads to the Monterey Bay. I've got some videos on that if you want to check that out. Okay, so we covered that. The water went right through here. And which way did it go? I'm sure it washed both directions. Almost every place you study that has massive erosion, you find the erosion going both directions. That's just something I've learned. And there's a reason for that. It's very important. But I'll let you ponder that for now. And then it leads right into this inland sea. Now, of course, tectonic forces play a huge role, but erosion plays a huge role as well. So let's see what this one's about here. Okay, now we're starting to see this is some drumlins in line with the current and has nothing to do with ice sheets. So we got drumlins coming across here. Perpendicular to that, of course, is the ripples. Very basic stuff that never gets talked about though. So I will repeat it many times. Another alluvial fan with a shoreline. And then we covered that. Let's check out this spot. Some nice ripples here. Very distinct and clear ripples. And let's get a wavelength. 15% of a mile. But wait a minute. hold the phone. Are these massive ripple formations? Yeah, I think that's what it looks like. Go over here. That looks kind of like ripples. We find drumlins here. And then perpendicular to the drumlins, as almost always, are the ripples. And then, yeah, these could very well be massive ripples coming across here. And then these being drumlins, which form perpendicular to that. Now, let's take a wavelength measurement. 1.7. Now, that's ridiculous. That's too much. Okay. Drumlins, more ripples. 72% of a mile. Pretty good. Okay, this spot's really cool. This is a favorite of mine. This desert is so arid, and yet it still has massive ripples in the valley. You can see the river valley, the ripple forms. Over here is another example. Okay, all of these are ripples. Why are all the deserts showing such incredible fluvial activity? I don't know, just take the erosion for what it is. That's what I do. People are always, commenting, why? Where did water come from? I don't feel like answering that question. I just report the erosion. But there is one source of water that's much larger than all the other sources of water on the entire world, so please feel free to believe that it's from the ocean. Plus, there's salt scablands all over the world, so it kind of makes it kind of obvious. All right, so we've got that spot. Let's see, do we check out this? Yep, those are the drumlins next to the ripples, as always. Beautiful. This is actually kind of cool. Oh, wait, this is what I'm... Yeah, well, this is cool as well. This is drumlins and then kind of into sediment lobes. Gets kind of messy. But you can see that it was pushed this direction. Wait a minute. The point of these sediment lobes, now it's going inland. Okay, this is how confusing erosion is. We're talking about a current that washed this way, but now we're seeing evidence of a current washing this way. I know, it's crazy. But that's what the erosion says. These are even streamlined, right? See the streamlined shapes? And look at how the water flowed around this here. A lot of good laminar flow. And no, it's not from the wind because see these ruts here? The wind's not going to create these river ruts here. And then you look at these river ruts and they're also streamlined, indicating the same current direction as well. Okay. This, I'm trying to find that spot. Okay, here it is. Now this little mount here has a river valley that goes all the way around it. So how does a river do that? Well, if there's sheet water flow flowing this way, it's going to dig out a river valley like that. So it's a really good streamlined feature here. And then we've got more stuff. Okay, now I want to talk, or let me just touch on these first. Yeah, so this is a good indication of mounds forming. All this water rivers, sculpted out these mounds, right? So that's how mounds form. Even this nice rounded one, that's from water sculpting them out. And then you, of course, get streamlined mounds. Very common to find streamlined mounds. But all mounds are made this way, from water sculpting it out. All sorts of rivers. So when sheet water flow decreases to river flow and then to stream flow, that's when you're going to get mounds being formed. And then what's this guy? Oh, some more of these. Okay, now I want to talk about this little spot in Baja. So if you guys saw my whole video and you think this whole thing is all bullshit, I will now convince you that everything I said is correct based upon this little section in Baja. So let's check, and it's all from the ocean, right? The ocean's a dominant eroder of Earth. It's by far the biggest and the strongest force of erosion. So it only makes sense that it'd make the biggest erosion that would leave behind salt all over the world. So here we've got sediment lobes, we've got drumlins, we've got streamlined features. Okay, nice streamlined features. We're going to follow this inland. We can see the way that we can, just from being, hundreds of feet above the earth with this satellite imagery, we can see the banks of the river. And then here we find some drumlins. And we kind of see how these paths went into this lake. And then really nice drumlins here. Really beautiful drumlins. Drumlins all over, and you would think drumlins would only be made by ice sheets because that's what they tell you. But yeah, I just really don't buy that, honestly. And then here we find some more drumlins. What is this? And now let's follow this path here. Now we're over on the other side. All right, we get some more ripples, even streamlined ripples. Okay, wavelength check. 6% of a mile, a few hundred feet. We see this line here. These are drumlins. This looks like a little sediment lobe. So then we find some more drumlins. We're going to follow this current. We're going to keep following it. And now we followed it into this salt scabland little ravine here, this big valley. This is from the ocean washing through here. So all of these drumlins and ripples show that water, the ocean washed through here and it washed through here. Okay, it's pretty plain to see. Zoom in, see if there's some ripples there. This is all scoured out. All of these are river ruts. Kind of a shallow cataract formation here. And some more drumlins. And now we get over here and we find a mesa, which is a terraced land. Terraced lands are terraced by sheet water flow, and then we find massive ripples on top of them. How clear is that? Wavelength, let's just, almost 500 feet in wavelength. So that's bigger than most of the ripples we find in Washington. Keep in mind we're on the coast of Baja California. And yeah, this whole landscape is covered in them. And not only that, but we actually see terraces next to them. So the river bank now is, where's the river? Yeah, so there's no river, but a small river bank. We can see one edge of the bank here. Probably if it flooded, it might go, this wide. But the valley was once filled, maybe here to here. And then before that, it was filled from here to here. And then from here to here. And then from here to this bank here, right? That's how that bank formed. And we can look at stuff like this and see these banks. And we can see how now it looks like the place we started in Oregon, because it also has mounds that streamline and spill off with terraces. So there you guys have it. And then, yeah, this spot here. Gotta love this valley here. It is just too perfect. And then you can see how a later, kind of a smaller river kind of washed away these ripples. So the ripples are only there because the water current ended so decisively. It's an important fact. And then this river here is pretty wide. Let's check it out. So it's over a mile wide. Still full of ripples. And then here, these ripples are pretty cool too. And then this, the reason why this land is, or these mesas are kind of separated like this, a strip of mesa here, is because we get that water current that washed down this way. So we get a current that's coming across these mountains, and that's why this ravine is horizontal. It has nothing to do with elevation change. It's not water washing downhill. It's water, it's from an ocean current, so it's water sweeping to the south or towards the north. So that's what creates this separation in that valley there. All right, thank you guys. Appreciate it. Stay tuned. Make sure to like, subscribe, share, follow me on Instagram, and share this with everybody you know. All right, appreciate it. Thank you guys. Have a good day.